What does it really mean for an AI to think? Today, we're diving deep into design patterns. Software complexity accelerates. Systems must scale, adapt, integrate across distributed environments. Design patterns provide a shared architecture vocabulary, codifying decades of engineering insight into reusable structural solutions. In an era of microservices, event-driven systems, and AI integration, the language of patterns is not optional, it's foundational. Strategic advantage: teams fluent in patterns design faster, communicate with precision, and ship resilient architectures. Ignoring patterns risks perpetual redesign and communication overhead. But here's where it gets interesting: the reusability gap. Most teams solve recurring structural problems in isolation. Architectural decisions, coupling, extensibility, object creation, control flow are reinvented per project, per service, per sprint. Code reviews catch style. Static analysis catches bugs. Neither catches architectural mismatch. Style guides enforce naming. They don't encode solution shape. The result: fragile integrations, inconsistent decomposition, and technical debt that compounds silently. Existing approaches lack a systematic catalog of proven design forms. So, what's the real problem? Let's talk about fragmented structural knowledge. Expert architects carry mental libraries of pattern-like solutions. This knowledge is tacit, untransferable, and lost when they leave. Teams without explicit pattern vocabulary default to localized optimization. Each new project rediscovers structuring principles, the root cause, a missing abstraction layer between requirement and implementation. Without named, documented architectural primitives, design knowledge remains fragmented across individuals, not embedded in the organization. This fragmentation directly increases onboarding time and design inconsistency. This raises a critical question: breakthrough, codified architecture. In 1994, Gamma, Helm, Johnson, Vlisides cataloged 23 classic design patterns. The insight: recurring design structures can be named, documented, and reused not as code libraries but as higher-order blueprints. Each pattern captures intent, motivation, structure, participants, collaborations, and consequences. Architecture became a language. Use decorator to add responsibilities dynamically. Patterns make design intent explicit, testable, and composable across systems. Patterns shifted design from craft to engineering. Now let's zoom in on the pattern ecosystem. Patterns organize into 3 categories, each addressing a fundamental force in object-oriented design. Creational patterns: abstract instantiation, decoupling client from concrete classes. Structural patterns compose classes and objects into larger structures, managing coupling and interface alignment. Behavioral patterns distribute responsibility and algorithm flow, enabling loose coupling and flexible interaction. These categories form a force-solution map. Patterns within each category group by degree of coupling, inheritance versus composition, and change isolation. This taxonomy makes the design space navigable. Here's something most people overlook: core pattern families. Creational, factory method, abstract factory, singleton, builder, prototype. Each separates object construction from use. Structural: adapter, bridge, composite, decorator, facade, proxy. Each shapes interfaces and composition trees. Behavioral: observer, strategy, command, iterator, state, template, method. Each defines interaction protocols and algorithm encapsulation. Each pattern resolves a specific tension. Observer decouples subject state from dependent views. Strategy makes algorithms interchangeable without client modification. Families are not silos. Cross-category composition is common. Think about this for a second. Pattern composition. Patterns are not standalone. Real systems emerge from pattern compositions. Model view controller layers, observer, strategy, and composite. Microservices architectures deploy proxy, adapter, circuit breaker, and service discovery together. A decorator wraps a strategy instantiated by a factory. Composition is not random patterns have affinities and constraints. Pattern languages describe clusters that co-evolve, enterprise integration patterns, cloud-native patterns, reactive patterns. The power multiplies when patterns combine predictably. Composition rules emerge from pattern relationships. And this is where things get complex. Pattern-driven development workflow. Analyze forces. Identify what must vary and what must remain stable. Pattern selection. Map forces to pattern intents. Structural adaptation. Resolve pattern participants to domain model. Collaboration design. Specify interaction sequences. Implementation. Apply structure, then add domain logic. Annotation. Label pattern roles in code and documentation. This workflow transforms design from intuition to applied mechanics. Every step is reviewable, teachable, and repeatable. Tools can scaffold pattern implementations automatically. But here's where it gets interesting. Measurable impact. Pattern fluency reduces design ambiguity. Teams converge on structure in minutes, not days. Onboarding accelerates new developers read architecture through pattern labels. Defect density decreases. Proven structures eliminate entire failure classes. Refactoring becomes guided migration from one pattern to another. Maintainability improves. Modules exhibit known coupling characteristics. Over time, the pattern vocabulary becomes an organizational asset, compounding across projects and teams. Empirical evidence. Pattern-based code bases exhibit lower cyclomatic complexity. So what's the real problem? Let's talk about organizational scale. A shared pattern language aligns architecture across squads. Design governance shifts from subjective review to pattern conformance. Reusable pattern libraries and reference implementations emerge. Distributed teams converge on structural norms without central command. Architecture decision. Records reference pattern names, reducing documentation volume. Scaling expertise. Senior architects codify patterns. Every engineer applies them consistently. The pattern catalog becomes the design DNA of the engineering organization. Fractal scaling. Patterns apply at class, module, and system levels. This raises a critical question: future, from patterns to automation. The pattern movement evolves beyond OP. Cloud-native patterns, sidecar, ambassador, adapter in infrastructure. Resilience patterns, circuit breaker, bulkhead, retoi. Event-driven patterns, event sourcing, CQRS, Saga. AI-assisted tooling now suggests patterns from context, detects pattern violations, and generates structural scaffolding. Pattern languages are being codified as infrastructure as code templates and architectural fitness functions. The trajectory: patterns become executable design policies. Design patterns are the seed for self-architecting systems. Now let's zoom in on design patterns, the architectural OS. Complexity will not decline. Systems will become more distributed, more autonomous, more demanding. The organizations that sustain velocity will be those with a shared, precise architectural language. Design patterns provide that language a composable, time-tested lexicon of structural intent. Invest in your pattern vocabulary. Encode your design decisions as patterns. Build architectures that speak, scale, and endure. They are the difference between code that works and systems that last.